Alright, this is our take 2 for lesson 3.2. I'm adding the audio back in, so there'll be some times whenever it may not match completely up. You'll see that we're talking about lesson 3.2, angles formed by parallel lines and transversals. And we'll be proving and using theorems about angles formed by parallel lines and a transversal. So we'll start off with the warm-up again. In this, I want you to identify each pair as corresponding alternate interior, alternate exterior, or same side interior. And so in just a moment you'll see what each of these answers should be. Angles 1 and 3 are corresponding. Angles 3 and 6 are alternate interior angles. Angles 4 and 5 are alternate exterior. Angles 6 and 7 are same side interior angles. Once again, most of your vocabulary should have already been filled out using your textbook, but here are the things you should have in those blanks. When parallel lines are cut by a transversal, all the angles formed are either congruent or supplementary. Corresponding angles postulate just explains that if the lines are parallel, all corresponding angles are congruent. Alright, so let's try example 1. In this example, we need to find the measure of angle ECF. So I've highlighted that one for you. ECF. And you'll remember that ECF and CBG are corresponding angles. And so the measure of ECF should be the same as the measure of CBG, 70 degrees. For the next problem, we want to find the measure of angle DCE, and that corresponds to ABC. So 4x plus 22 should be the same as 5x. So take a moment or two and try and solve that equation. Pause the video if you need more time. And then plug it back in to find out what the measure of the angle is. This is what you should get. We're going to subtract 4x from both sides. 22 equals x. If I plug that back in, 5 times 22 is 110. And this should match up. If I take the 110 degree angle plus the 70 degree angle we found first, those should add up to 180 because they form a linear pair. And they do. So here are the next theorems you should have: alternate interior angles theorem, alternate exterior angles theorem, and the same side interior angles theorem. And all these basically start off the same way. We start off with two parallel lines cut by a transversal. If we have two parallel lines cut by a transversal, alternate interior angles are congruent, alternate exterior angles are congruent, and same side interior angles are supplementary. So in example 2, we're going to use those facts to find the information here. So in 2a, we want to find the measure of EDG. Alright, now that angle, EDG, is the same as angle FBC. Now, you could start to do a whole lot of work here, and the first time through the video, if you were watching without the audio, I went ahead and said x minus 30 equals 75, and we tried to solve that for x, but we really didn't need to. Okay, and so what you'll notice here in just a moment is we can skip ahead because we know EDG is an alternate exterior angle with FBC, so they both should be the same measurement. That means EDG is 75 degrees. So this problem's a little bit easier than the way it originally seems. And so we can just say the measure of angle EDG is 75 degrees. In part B, we are going to try and find the measure of angle BDG, which is the expression for x. And that is where we will do our x minus 30 equals 75. And by adding 30 to both sides, we can find out what x is, and that'll tell me the value of 105 degrees, which is the measure of angle GD, or BDG. Now in part B, we're going to use, or part C, excuse me, we're going to use a different diagram. We're going to find the measure of angle ABD, which has the expression 2x plus 10, and that is an alternate interior angle with 3x minus 15. So we know those should be equal because the lines are parallel. So I'm going to set those two expressions equal to one another. And solve for x. This is a chance for you to pause the video and try and solve for x quickly, and then we'll plug that back in and get this. By subtracting 2x from both sides and adding 15 to both sides, we get x is 25. We plug that in. The measure of ABD would be 60 degrees. Again, pause the video if you need more time to look at any of this. Example 3, we are going to try and find x and y, but you'll notice that we have three parallel lines cut by two different transversals. Along this transversal P, we have an angle 55 degrees and then another angle 5x plus 4y degrees. Along this transversal Q, there's an angle here marked 60 degrees and an angle here expressed as 5x plus 5y. When there are two variables in both expressions, we will most likely need at least two equations to solve to get those variables. That's called a system of equations. You'll remember we did this a little bit last week. So to find x and y, we're going to write two different equations. So we're going to solve a system of equations. So first let's look at transversal P, which intersects lines L and N, which are parallel, and we get the 5x plus 4y equation and the 55-degree angle. Those are alternate interior angles, so they should be congruent because the lines are parallel. So we can say 5x plus 4y equals 55 degrees. And that's one equation. But we have another set of angles to look at. Transversal Q intersects lines M and N, creating these corresponding angles, 5x plus 5y and 60 degrees. Those should be equal. So that's where we get our other equation. So if we solve this system, by the elimination method we looked at, if we just added the columns, we wouldn't get anything to eliminate. However, if we take the opposite of every term on the bottom, or subtract each column instead of adding, we should be able to eliminate the x's, because 5x minus 5x will be 0. So let's take a look at what happens when we do that. Again, we're going to subtract every column. It's like we just multiplied the bottom equation by -1. And then the x's cancel. We get negative 1y equals negative 55, or negative 5, I'm sorry. Divide by -1 on both sides, so y is 5. Now we have to solve for x by plugging 5 back in for y. So we're going to go back to either one of the original equations and plug 5 in for y. So we have 5x, I'm choosing the top equation, plus 4 times 5 for y equals 55. 4 times 5 is 20, so I'm going to subtract 20 from both sides, and 5x equals 35. Divide by 5 on both sides, and we get x equals 7. Now, we can write our answer just like this, or we can write it as an ordered pair. X is 7, y is 5. That's the values for x and y you were supposed to find. All right, here's a helpful hint. If a transversal is perpendicular to two parallel lines, all 8 angles are congruent, because they would all be right angles, and we know that all right angles are congruent. All right, one final thing I would like for you to do. I've drawn two parallel lines here cut by a transversal and labeled all of the angles. I want you to make a list of all the angles that are congruent and all the angles that are supplementary. So pause the video, take a moment or two to do that. Here's what you get. The congruent pairs of angles are 1 and 3, 5 and 7. Those are all congruent to each other. Also 2, 4, 6, and 8 would also be congruent to each other. But here's a list of supplementary pairs. Now, this is not the entire list, but it is most of them that you would have. So either as linear pairs or same side interior angles, we would have supplementary angles here. 1 and 4, 3 and 4, 3 and 6, 4 and 5, 6 and 7, 7 and 8, 5 and 8. All those different pairs are on this list. So hopefully you've been able to understand things a little bit better with the audio this time. If you have any questions, feel free to ask during class.